In this video, I will show you how to analyze a velocity time graph using the example here. At t equals to 0, a particle moving along a line passes the origin O. The graph below shows a variation of the velocity v of the particle with time t. Part A, by doing calculations, explain in detail the motion of the particle. Then part B, find the displacement of the particle from the origin at t equals to 24.0 seconds. First, let us take the line along which the particle is moving to be an x-axis, and therefore I will place x hat to indicate the positive direction. For part A, we are going to analyze first the time interval t equals to 0 to t equals to 10.0 seconds, and what we see here is that the velocity is positive over this time interval, and since the velocity is positive, it means that the velocity vector points in the same direction as the x hat. When we look at the value of the velocity, we see that it increases from v equals to 0 meter per second to v equals to plus 20 meter per second. And as we can see, the value has increased, and therefore we conclude that the speed has increased. Because if you remember well, the magnitude of the velocity is the speed. Now let us look at another quantity called the acceleration, which can be found from a velocity time graph. The acceleration is simply the gradient of the velocity time graph. From t equals to 0 to t equals to 10.0 seconds, we have a straight line with positive gradient, which therefore means the acceleration is positive. A positive acceleration means that the acceleration vector is in the same direction as our x hat. And since the velocity time graph is a straight line over this time interval of the motion, it means the acceleration is uniform over this time interval. So remember this, whenever we see straight lines on a VT graph, we conclude that the acceleration is constant. If we calculate the gradient of the line over the interval 0 to 10.0 seconds, we obtain the acceleration equals to plus 2.0 meter per second square. So the plus means that the acceleration vector will point to the right in the same direction as our x hat. So a very important point to note here is that when the acceleration is in the same direction as the velocity, the value of the velocity increases, or in other words, the speed increases. Another quantity that can be found from a velocity time graph is the displacement covered, which is equal to the area under the velocity time graph. From t equals to 0 to t equals to 10.0 seconds, the area under the velocity time graph is above the t-axis and therefore is positive. So a positive area means a positive displacement, and therefore this displacement covered is in the same direction as our x hat. The displacement covered in this time interval is simply determined by calculating the area of the velocity time graph from t equals to 0 to t equals to 10.0 seconds, and here it is simply a triangle, and therefore we can use the formula for the area of the triangle, which is half times 10.0. 10.0 is the base, and multiply by 20, where 20 is simply the height. So the displacement covered over the time interval 0 to 10.0 is plus 100 meter. So the plus is telling us that the particle has covered 100 meter in the direction of x hat. Now let us examine what is happening from t equals to 10.0 second to t equals to 15.0 second. In this time interval, the velocity is positive, and this means the particle is moving in the direction of x hat. So each time you have velocity to be positive, you always remember that the particle is moving in the positive direction. Also, the value of the velocity changed from 20 meter per second to 0 meter per second, which means the speed decreases over this time interval, and when speed is decreasing, we call this a deceleration. In this time interval, we have a straight line with negative gradient. The negative means that the direction of the acceleration is opposite to the direction of x hat, and therefore will point to the left, and the straight line shows that the acceleration is uniform. The gradient of this line is a equals to minus 4.0 meter per second squared. So in this time interval, the velocity is positive and therefore points to the right, and the acceleration is negative and therefore points to the left. This means that the two vectors are opposite each other, and therefore the speed will decrease. So this is something very important to note, which is that when the acceleration vector is opposite to the velocity vector, then the speed decreases and we have a deceleration. The displacement covered in this time interval is found by calculating the area of the triangle with length 5.0 second and height 20 meter per second. And if we do this, we should obtain delta S equals to plus 50 meter, where the delta S is simply our displacement covered. At t equals to 15.0 second, the velocity is 0, as you can see on the graph clearly. But however, the line has a gradient, and the gradient is simply the acceleration, which means at t equal to 15.0, although the velocity is 0, but the acceleration is not 0 and is equal to minus 4.0 meter per second square, which is simply the gradient of the line for the interval 10.0 second to 18.0 second. Now this instant where the velocity is 0 but there is an acceleration, we call this instant the instantaneous rest instant. From t equals to 15.0 second to t equals to 18.0 second, the velocity is now negative. And this means the velocity is opposite to the x hat direction, or in other words, is pointing to the left. So the direction of motion of the particle over this time interval is in the left direction. In this time interval, the velocity has changed from 0 meter per second to minus 12 meter per second. Now there is a very important point to note here as well. Even though the velocity has changed from 0 to minus 12 meter per second, the value has still increased, because minus 12 and 0, minus 12 is greater in value, in magnitude is greater than 0, which means that the speed has increased because speed is simply the magnitude of the velocity. The acceleration over the time interval t equals to 15.0 second to t equals to 18.0 second is negative, because this is a negative gradient line. And if we calculate the gradient, we obtain the acceleration over this time interval as minus 4.0 meter per second squared. And this is simply telling us that the acceleration is 4.0 meter per second squared, and it points to the left. Here we see that the acceleration is negative, meaning minus 4.0 meter per second squared. And the velocity also is negative over this time interval, which means the acceleration vector and the velocity vector are in the same direction. And when the acceleration and the velocity are in the same direction, the speed will always increase. So this is not a deceleration even though the acceleration is negative. They are both pointing in the left direction. Therefore, we conclude that the particle is speeding up. The displacement covered in this time interval is simply the area of the triangle with base 3.0 second and height minus 12 meter per second, and we should obtain delta S, which is the displacement covered, as minus 18 meter, which is simply telling us that the displacement made by the particle from t equals to 15 second to t equals to 18 second is 18 meter to the left. From t equals to 18.0 second to t equals to 24.0 second, the graph is horizontal. A horizontal line on a velocity time graph simply means there is no acceleration and that the acceleration is 0. And here, at t equal to 18.0 to t equals to 24.0, the velocity is constant and is equal to minus 12 meter per second. And the minus simply means it is moving to the left. The acceleration is 0 as the gradient of a horizontal line is 0. The displacement covered in this time interval is equal to the area, which is simply the area of a rectangle with width 6.0 second and length minus 12.0 meter per second. And if you calculate the area, you should get the displacement covered, delta S, equals to minus 72 meter. The minus simply means it moved 72 meter in the left direction. Now for part B, all we need to do is to add the displacement covered over the time intervals and obtain delta S equals to 100 plus 50 minus 18 minus 72, which should give you 60 meter, which means the displacement covered over the time interval t equals to 0 to t equals to 24 second is 60 meter to the right. Now how do I know it is to the right? It's because the 60 is positive.